Now here's a big one. Many times, in particular with root 18, I've used in assessments over the years for year 11 students. And it's a non-calculator section. They've got no idea what to do with it. And what it does is it throws their brain off being able to do the other calculations. For example, they're drawing a graph and one of the points where it crosses the x-axis turns out to be root 18. Or whatever it is, root 17 or root 63 or root 5, and people don't know what to do with it when they want to draw the graph. Really, in simplicity, this is somewhere between root 4 and root 9. So we're thinking about the nice numbers. I'm always talking about the nice numbers, and the nice numbers are these squares. And when you talk about squares and nice numbers, of course, we're talking about 2 2s are 4, 3 3s are 9. I know it's obvious to a lot of people, but when I'm marking, I just see so much where people mess up. Now, even with my grandchildren, they nag about these, even if they're not good at their times tables, so I nag about those all the time. So, root 4 would be, if I got a red pen, root 4 would be 2, and root 9 would be 3. So root 7 has to be somewhere between that and that. And if you're thinking about root 7, you go, there is a little bit where you can go, is it closer to root 9 or is it closer to root 4? But it's not linear. It's not a linear relationship. It's a curve. So I could look at that and say, it's probably a bit closer to root 9 than it is to root 7. So I could just go, it's about 2.6. So if I was drawing a graph and I needed 2.6, here's the easy part about drawing a graph at 2.6. If that was my graph there, you go 1, there's 2, and there's 3. And you go, how accurate does it have to be? What if I had 2.5 or 2.7? Very hard to tell the difference on the graph where it would be, whether it was there or there or there or there. So somewhere in that vicinity is going to be the right answer. By the way, over here I've got written down that it's actually 2.65. So just a rough estimate. If you said 2.5, would it be too rough? No. But you could be a bit careful and see what was happening. So, root 18 has to be between, let's look at the magic numbers. So, root 16 would be 4, root 25 would be 5, so it's somewhere between root 16 and root 25. So, root 16 and root 25. So, some of you got the hang of it now, you probably don't need anything more. So, root 18 would be closer, it's got to be closer to root 16 than root 25, a lot closer. If I had a look at it and I said, well, that's 4 and that's 5, I could probably guess 4.2. What if I said 4.3, 4.1? What if you said 4.15? I wouldn't know which one to guess, and I've got it over here. And by the way, I don't know this off by heart, and it turns out to be 4.24. So by the way, you could have said 4.25, you could have said 4.3, anywhere around there. One more for good measure, just in case those who need to watch it. So what about between root 60 then? Root 60 is between square root of 49, because the square root of 49 is 7 and the square root of 64 is 8, in case anyone's struggling with it. So we want somewhere between 7 and 8, somewhere between root 49 and root 64. And stop again and do that. So there's our root 60s. Probably going to be, I even write it like almost like a number line. It's closer to there. So it's probably, if that's 7, and that's 8, I'm going to go, it's probably about 7 point, I want to go about 7.8, and I don't know the answer. I did write it down a moment ago, but I can't remember what I had. So 7.8, the actual answer is 7.75. So just a rough guess, and it works well enough for graphing. Oh, such an important point. I just see so many people mess it up, and I don't think a lot of people teach it or nag about it. So if it's helping, just please press like, it helps. Tell your friends, and if you haven't subscribed, if you subscribe, that's really helpful. Thank you.